Okay, this next problem is a daily growth of world population problem, and it's actually number 25 in your book. And so let's go ahead and just make this a little bigger to explain this. So on average, every minute of every day, 155 babies are born, okay, on average. This bar graph represents the result of a single day of births, deaths, and population increase worldwide. So we're going to do number 25, obviously, are based on, well, the information displayed by this graph. So daily growth of population, right? So it's a horizontal histogram bar. So we have the number of births, right, in a single day, deaths, and then of course population increase. And so the births, right, notice, right, probably 380, right, in thousands. So about maybe 380,000 births happen on a single day. Again, this is an average. Deaths, about 150,000. And then, of course, there's a population increase here, of course, which depends on the number of births and the number of deaths. Right, and here's the source. And each day, so number 25, each day the number of births in the world is 84,000, less than 3 times the number of deaths. So let's translate this algebraic expression into, well, this English phrase into an algebraic expression and eventually an equation. So we're talking about the number of births, okay, so I'm just going to call that B, is, okay, 84,000, less than 3 times the number of deaths. So, maybe call deaths D. So again, what are we looking for, right? We're given a lot of information, but what is the goal of the problem? Let's write that down again instead of maybe writing a bunch of information and forgetting what the goal is. So what are we looking for? Well, the problem in part A, it says if the population increase in a single day is 228,000, determine the number of births and deaths per day. Okay, let's write that out. We're looking for the number of, right? It says determine in your book. I don't have it on here, but in your book it says determine the number of deaths per day. So I'm just gonna let maybe, okay, so let X be the number, right? It's a word problem. You have to tell me what your unknown represents. The number of deaths, right? This is, of course, in thousands per day. Okay, and you have to be specific. You have to say per day. It's not, per week, per month, because the problem specifically says per day. And again, I wrote, I let X be the number of deaths as opposed to births because the number of births is described, right, in terms of deaths. So usually, again, the last quantity here, or depending what you're talking about, is usually what your unknown is going to be, what your X is. So if X represents the number of deaths per day, okay, then what's the number of births, right? Maybe per day, right? And we can, call that B if you'd like. But if not, the number of births per day, well, the number of births, okay, I'm describing it here, in the world is 84,000, less than 3 times that, 3 times the number of deaths. So again, there's that less than. And so we have 84,000, right, less than 3 times the number of deaths. And again, let's color code here. That's blue, right? That's blue. So if we find the number of deaths in thousands per day, then we can definitely find the number of births per day. And finally, the problem says, in part A, it says if the population increase, okay, in a single day is 228,000. Well, the population increase, right, depends on these guys, right? It's the difference. So we have the number So number of births, of course, right, per day. And then we're going to subtract the number of deaths per day. And that's going to give us our 228,000. Okay, so let's substitute what we have. Well, the number of births per day, that we call that X, right? This guy right here. And then, actually no, the number of births per day is not X. The number of births per day is right here, right? Number of births. So that is 3x minus 84,000 minus, and then the number of deaths per day, well, that's what I called X, equals 228,000. And again, this is just 6.3. 3x minus 2x, 3x minus 1x is 2x. So all I did was combine like terms, and I have a constant on the left hand side and a constant on the right hand side, so I can definitely move my 84,000 over. And that's gone, right? Because our goal is to solve for x, and so right now we're left with 2x, and we get to do some additions. So 0, 0, 0, 12, 11, so 2x equals, okay, that's 312,000. And so we ask ourselves, well, 2 times what number, right, gives me 312,000? Well, I mean, all you have to do is divide by 2. Why? Because you want to make this a 1. You're looking for 1x. And if you divide 312, right, if you cut it in half, you get 156,000. So x is 156,000. Okay, well, what is does x represent? Well, if we go back up, you defined it, right? You wrote, or I wrote, which you're going to write, the number of deaths in thousands per day. So that means that there's 156,000 deaths per day. Okay, so the problem asked, let's see, we want the number of births and deaths. So these are the deaths per day. So what about the number of births per day? Okay, well, what was our expression for the number of births? Well, it was right here, right? It's 3x minus 84,000. So we use this guy, 3x minus 84,000. But we know what x is, right? It's right here. So we're going to evaluate, right? When x is 156,000, right? That's going to give us the number of births per day, right? So then, again, punch this in your calculator. And again, you have to multiply the 3 times the 156 according to the order of operations. So we get 468,000. And then you just subtract your 84,000, and then your total is going to be 384,000. Okay, so this is the number of, again, births per day. And I mean, if we wanted to check our answer, right, again, you have to ask yourself when you're doing these work problems, does this make sense? Well, what did the problem, tell us? So again, this is 25, and there's part A here, which is in your book, and it says if the population increase in a single day was 228,000, which we did write down. Well, if you subtract these guys, do you get 228,000? And again, if you check, right, it was, well, 384 minus 156,000. And if you, again, if you subtract that, do you get 228,000? And the answer is yes, it does check. So that is the population increase. It does make sense. If you didn't get 228,000, again, that means you just go back to your problem and see if maybe you forgot a negative sign. So again, with these applications, right, these are word problems. So again, I'm going to need to see your words. I need you to define your information, to construct your algebraic expressions, right? Tell me what you're going to construct, right? Label these guys. And yeah, that's pretty much it. And then you're just using 6.3, right? All this is 6.3, right? Dot, 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 and checking. The only new part is this guy, right? And constructing. You're actually constructing this linear model. Okay, so that is the daily growth of world population problem.